These are the worked out solutions for the study guide for the second benchmark test that we will take. It says up on top there's 64 questions. They're all multiple choice. There's 69 questions for the advanced algebra class, and questions 1 and 2. So questions 1 and 2 are going to ask about properties, number properties, and basically the answers are either going to be the commutative property of addition or multiplication, associative property of the same two operations, distributive property, inverse and identity properties. So taking a look at the first one here, we've got an x plus 8, and it equals x plus 8 again, but times by 1. So what changes? Well, the only thing that changed is this right here. See how they have a times by 1, and when we times by a number by 1, we get that same exact number. Notice how these two are exactly equal. So when we go ahead and look at what property we're dealing with, we're dealing in this case with the identity. Identity property of multiplication is when you times a number by 1. Looking at the next one here, we got two numbers. One's a 3 and then the other's a 2. But over here we got 2 and a 3. Here we're using the commutative property of addition. It says that we can move the terms around and still get the same answer. Over on this next one here, notice how we've got a 32 and a plus 4x, but on the other side we've got a parenthesis, and we got 4 on the outside of it. Well, what happens, what property is it that we can multiply the number outside by each of the numbers inside and get that answer? See, 4 times 8 is 32. 4 times x is 4x. Well, our answer would be the distributive property. Well, let's take a look at another one here. Here we have opposite signs, but the same number. Negative 4 and 4 equals 0. That's an inverse property. Inverse of addition. Over here we have the same order. Always check the order. Check it and see if it's that commutative property. 3, 2, 1, 3, 2, 1. Same order, so not commutative. So what changed is the parentheses. See how it's around the 2 and the 1? Here we switched it. It's around the 3 and the 2. And that's called the associative property of addition in this case. And over here we have 5, 2, 1, 5, 1, 2. See, it almost looks like the associative, but look, the 2 and the 1 are still inside the parentheses, so it's not associative. Associative is only when the numbers change inside the parentheses. Here they have it. But what did change? Well, it's the order. 2 is first here, then 1. Here it's 1, and then 2. So this is the commutative property. Commutative property of multiplication this time. So those are some of the properties you'll end up having to deal with. And questions 3 and 4 ask about opposites and reciprocals. So you're going to have one opposite and one reciprocal. So opposites are sign. So sign only here. And when we're dealing with reciprocals, we're dealing with turning the fraction. So this is a switch of the fraction. So that's what you'll be looking for as you do this. So over here I've got negative 3/5. Well, in this case, this opposite would be just 3/5. Here we have the reciprocal it's asking for. And so this is where we turn the fraction upside down. So opposite, well, here it's negative. So the opposite is going to be a positive. Here are the reciprocals when we turn the fraction upside down. Opposite, change the sign. Reciprocal, sign stays where it's at, but you got to turn the fraction upside down. So it doesn't matter where the sign goes. You could have the answer like this, negative 2 over 3x squared. You could have the negative sign down below as well, and that would still be a good answer. Well, opposite again is just changing the sign. So numbers stay where they're at, just the sign will change from a negative in this case to a positive. Reciprocal, turn the fraction upside down. Oops, it didn't do that. So let's fix that. So again, reciprocal, turn the fraction upside down. Sign will stay the same. Opposite, different sign. Well, those are opposites and reciprocals. Let's take a look at the next set. This is going to ask us about exponent rules and also taking roots. So it's what we've done recently. And so you've seen these. These should be easier problems for you because you have done them recently. Questions 5, 6, 7, 8, and 9 are on this. So here we have the square root of 81 and the square root of 100. And so we go ahead and take the square root of 81, that's 9. The square root of 100 is 10. That would be our answer. Remember, the number outside here in the index portion is the number of roots. So you're looking for 3 numbers that multiply to make 8. And that's all raised to the first power. Same thing over here, 3 numbers that multiply to make 27, and all raised to the first power. So those 3 numbers that make 8 are 2. The 3 that make 27 are 3. So 2/3 is the answer. So over here, square root of 64, well, that's just 8. And then we have let's fix that 8. Doesn't look too good. We've got the square root of 64 we said was 8. The cubic root of 125, well, that's 5, 5, and 5 make 125. So the number is just 5. Then this is the 4th root, so 4 numbers that make 16. It's not 4, it's 2's. See, 4 2's end up multiplying to make 16. Then you just add, so you get 13 minus 2. That's how you get 11. That would be our answer. Over here, when we have fractional exponents, we just look at the denominator. It represents the number of roots. So it's 2 numbers that make 4, all raised to the first power, times 4 numbers that make 16, again, all raised to the first power. Because the numerator represents the power, the denominator represents the roots, how many roots we have. So over here, 3 numbers that multiply to make 8, all raised to the first power. So we go ahead and do some work there. We've got 2 that make 4 is 2, and 4 that make 16 is also 2, and 3 that make 8, well, that's 2 as well. Well, 3 2's all multiply to make 8. That's how they get the answer. Looking at the next one here, we have to remember some rules about exponents. Any number to the first power is just that number itself, so we have 10. Any number to the 0 power, that just cancels out. Remember, that makes 1. So times by 1 doesn't change anything. I'll just put it there for now. And then the cubic root of 27. So it's just asking about exponent rules, seeing if you remember them. So you go ahead and figure out the number of 3's, or number of numbers that make 27. There has to be 3 of them. That is 3. And 10 times 3 does make 30. So there's our answer. Well, over here we've got more exponent rules. We've got a 3 on the outside of a parenthesis. Well, all you're going to do when the number's on the outside is multiply those exponents. So we've got a to the 15th. We've got a b to the 6th. And over here we just have an a. And if you don't see an exponent, it's 1. It's a to the 1st, b to the 4th. So you go ahead and count up how many a's you have, how many b's you have, and see what you have there, and that'll be your answer. So here we have 15 a's and 1 a makes 16 a's. And then the b's, well, we have 6 and 4 make 10. So there's our answer right there. Well, let's take a look at the next one. More exponent rules, this time no multiplication. Here you're just adding them up. And so we have a to the 9th. So again, I'll show that with an addition sign here. 9 plus whatever the exponent is on the other a. Well, in this case, it's just 1. And then it's multiplied. So let's fix that. So times by b to what powers? Well, they have 2 and 3. So all you're doing from that point is just counting up how many a's you have. In this case, we have 10 a's. And over here, 5 b's. So there's the answer, a to the 10th, b to the 5th. Well, in this next one, it's just same sort of thing. It's just asking exponent rules, just showing you in different ways. It may have numbers rather than variables. So in this case, we can combine these two first. Count them up. you got 3 9s and 4 9s. Add those up and still all to the 7th power. So we go ahead and do some more work there. And we can count up the number of 9s. We got 9 to the 7th, and still all brought to the 7th. So what this means is 7 groups of 9 to the 7th. So if we wrote out 9 to the 7th 7 times, you count up all the 9s, and that would be 49 altogether. So the trick is, when the number's on the outside of the parenthesis like this, the exponent is, you multiply exponents. And we get a chance to do that again on this next problem. So looking at this one, when you see the exponent on the outside, the rule is multiply the exponents. So we have x to the 4th times by 3, and we have y to the 1st times by 3. And so when we do that work, we get x to the 12th and y to the 3rd power. Over here we have an exponent of 1 if you don't see it, especially on the coefficients. Don't forget about that one. And then you distribute. See what you have. So it's 3 to the 2nd, x to the 8th. So the common mistake people are going to make is they're going to say this is 6, but it's not, because 3 to the 2nd is 9, not 6. So it's 9x to the 8th power. Well, in the next problem, we have to reduce some fractions. So think of this as 3 separate problems. And the part I've seen some people make an error on here is they subtract the coefficients. So that's not what we do. We're going to reduce them. So I'm going to rewrite this, just separate the numbers a little bit. 32, I got an x to the 2nd, I got a y to the 3rd. Down below, got that 24, x, and y to the 8th. And so over here, I'm going to go ahead and reduce the fraction. I see 8 goes into these numbers, so I'm going to divide this, both the top and the bottom, by 8. And then I'm going to cancel out 1x here, take away 1 from the top, leaving me just with 1x on top. Take away these 3 y's and 3 y's from the bottom. Let's see what's left over. So I've got 32 divided by 8 makes 4. And let's write down how many x's we have. It just is 1x. 24 divided by 8 makes 3. Notice that the 3's on the bottom, and also the y's are. 8 minus 5 makes 3, or 5. 8 minus 3 made 5. So we have, fix that 5 real quick. So we have 4x over 3y to the 5th power. And there is our answer. Well, one more problem to try, similar to what you'll see on the test. Let's go ahead and, again, spread these numbers out a bit. 36, and before I do this, I see some negative exponents. When you see the negative exponents, switch their location right away. So 36, I've got the z's going on top now, so z to the 3rd, and then this y to the 0 makes 1, so I don't need to worry about that. Down below I have the negative 13, and I just have an x to the 1st power. And that's it. Well, I see that 13 and 36 don't have any common factors. 26, well, 13 goes into 26, but not 36. So that's our answer. You can't take out the z's or the x's, so we can't go any further than that. And the key on this one is to remember that any number to the 0 power, just a 1. Well, the next part we'll go over more questions on this test.